on to the next wow video here. Part 284C3m1b4. Line 22f1fa19c3m1b4. Impedance Induction Coil, PROTO, SPHERA, Neutrinos, 5G Wow Seti. So there's the alien radio signal there. So I googled impedance induction coils to find out what would come up. And November 22nd was when I was working on it. Today's the 24th. Google the following keyword to see what it brings up and look at the images to see if anything stands out. I found an experiment that looks like the idea I had for a new Tevatron neutrino collider. It needs the mirror formulas added to it from the WOW videos. So quotes from Wiki: an induction coil or spark coil, archaically known as the Inductorium or Ruhmkorff coil after Henrik Ruhmkorff, is a type of disruptive discharge coil. It is a type of electrical transformer used to produce high voltage pulses from a low voltage direct current supply. To create a flux change necessary to induce voltage in the secondary, the direct current in the primary is repeatedly interrupted by a vibrating mechanical contact called an interrupter. So, quote from a PDF: impedance of an induction coil at the opening of a borehole in a conductor. There's the name of the scientist that worked on it. It's from Greece and USA. 2007-2008. The electromagnetic field of a cylindrical eddy current probe coil near the open end of a borehole in a conductor has been calculated analytically, accounting for edge effects. Calculations of the coil impedance as a function of position and excitation frequency have been made, allowing theoretical results to be compared with experimental measurements. Comparisons have been carried out for special cases in which a cylindrical coil has its axis either perpendicular or parallel to the axis of the hole. In the approach used, the field is expressed in terms of transverse electric and transverse magnetic potentials defined with respect to the axis of the hole. The domain of the problem is truncated in the actual direction in order to express the solution in the form of eigenfunctions expansions. The truncation modifies the original unbounded domain problem, but the additional boundaries can be made as remote from the coil as desired so that they can have a negligible effect on numerical estimates of the coil field. The truncated region approach has proved to be accurate and computationally efficient, but more significantly, it allows new solutions to be found for problems that are otherwise analytically intractable. The results model eddy current inspections of boreholes, including edge effects at the opening of the hole. And that's from jap.aip.org. So here's a diagram here for you to look at. Notice this shape here. It's the shape of our spaceship. Left. The field, this is a quote from Wiki: fields due to stationary electric and magnetic monopoles. Right in motion velocity v, an electric charge induces a B field while a magnetic charge induces an E field. Conventional current is used. Okay? Here it is again. Top E field due to an electric dipole moment. Bottom left is a B field due to a mathematical magnetic dipole and formed by two magnetic monopoles. Bottom right, B field due to a natural magnetic dipole moment and found in ordinary matter, not from monopoles. The E fields and B fields due to electric charges, black, white, and magnetic poles, red and blue. Okay. November 22nd, my thoughts. The electric field and magnetic fields for the bottom of the spaceship and the space elevator to help it rise around in a circular motion. As a pulse beam reflects off each mirror, this moves the electric charge magnets on the ship in an upward motion. Data quotes from Wiki. There's the idea there. Area defined by an electric coil with 3 turns. For example, a change in the magnetic flux passing through a loop of a conductive wire will cause an electromotive force, and therefore an electric current in the loop. This relation is given by Faraday's law, and there's the equation, where E is the EMF. The symbol is the magnetic flux through the open surface of that. Is the boundary of the open surface. Note the surface in general may be in motion and deforming, and so is generally a function of time. The electromotive force is induced along this boundary. So this symbol is an infinitesimal vector element of the contour V is the velocity of the boundary, E is the electric field, and B is the magnetic field. Okay? The two equations for EMF are firstly the work per unit charge done against the Lorentz force in moving a test charge around the possibly moving surface boundary, and secondly is the change of magnetic flux through the open surface. This equation is the principle behind an electric generator. There's another little graph here. For an open surface, the electromotive force along the surface boundary is a combination of the boundary's motion with velocity v through a magnetic field B, illustrated by the generic F field in the diagram and the induced electric field caused by the changing magnetic field. So November 22nd, I'm going to Google the keyword magnetic flux examples to see images. I'm going to Google for more research November 22nd. Quote, a configuration very similar to PROTO SPHERA was obtained on the TS3 experiment, University of Tokyo in 1991 to 93. The configuration set up on T3 was smaller than the PROTO SPHERA by a factor of about 1.6 in linear dimensions. The screw pinch discharge was initiated breaking down VE and the filling gas to that between the two plasma guns used as electrodes. The toroidal plasma was formed, increasing the arc current up to the nonlinear kink and stable threshold. At this time, the current of the compression coils was pulsed. The magnetic field measurements confirmed the establishment of a flux core spiral MAC, whose formation from the longitudinal electrode current was attributed to the n=1 kink mode, which was able to convert the magnetic flux from polyidal to toroidal. And that's from www.frascati.enea.it. Okay? So here's some pictures. Magnetized coaxial plasma gun, compression coil, external field coil, center Z discharge electrode, and center bias coil. So this is figure 2.3, the flux core spiral MAC configuration of TS3, number 68. And here's the other design. See that design there? Scheme of the DC helicity induction and PROTO SPHERA. This is very important, this design here. Okay? Closed flux analyst, flux conserver, gun solenoid, electrodes, Marshall gun. Scheme of the specs experiment you missed, figure 2.18. And here's the PROTO SPHERA, SPHERA and the pinch. And this is the figure 2.20, values of URSPH for the formation compression of PROTO SPHERA, along with the values obtained in the TS3 compression experiment. Okay? The graph quote sources from the frascati.enea.it. Okay, thank you for watching, and we'll go on to the next video soon.